everyone. My name is Denis, and today I'm going to talk to you about working in small batches and overcoming cultural barriers. And I explain what is it to do with continuous delivery at all, and what do I mean by cultural barriers. First, a little bit about me. I work for a company called Bloomberg. I've been with them for 14 years. I started my life there for majority of the time as a developer, working on weather data and energy data and providing energy forecasts. I also have been a leader of internal community we called Automated Testing Guild for almost 8 years now, where we focus on automated testing, developer productivity, and how it affects delivery of software. And a little bit about a year ago, I joined an infrastructure team, internal infrastructure team, focusing on continuous delivery and tools. So this is kind of my background. First, I want to start by defining continuous delivery, because as you probably know, there's a lot of definitions. I'm sure you all know what the definition I'm going to choose this time. I'm going to rely on those two books, one from Continuous Delivery 2010 and Accelerate 2018. Show of hands, who read any of those books? Who read at least one of them? So at least both of them. I think in some sense they're still they're both still state of the art, and I will heavily rely on Accelerate and the research been done in there, and all the analysis they perform. But starting with definition, the Accelerate defined continuous delivery is the capability to make any changes and deliver them all the way to users safely, quickly, and sustainably. And it's like, I like this definition. On one hand, it's nice and simple. We should just take it and implement it, right? What can possibly go wrong? Well, it's not quite as easy, right? And I think continuous delivery success is really two challenges. And I have chicken and eggs, right? I didn't know what the theme, but chicken and eggs are here, so we're going to talk about eggs as well. So there is two challenges. There is a culture challenge and there is a technology challenge. And I assume majority of people in the room are engineers. Show of hands, right? Yeah, majority of engineers, and we love the technology challenge, right? We love to tinker and solve something with a tool, automate something away. This is great, and it can get you quite some way. But at some point, you realize that you're not hitting like the expectation you were hoping to get with using this tool. And at this point, you kind of start realizing that there is also this culture challenge, right? Do teams, department, and organization change their existing values, habits, and behaviors in order to be successful with whatever tool we're applying? Again, tools create opportunity, right? If tools is available and it's off the shelf, or it's already something someone else adopted, like you can just take it and this is great. But the culture change creates a demand for, like, I need this capability, I need to do this in this particular context. So that's why it's a little bit chicken and egg, right? Like, tools can change culture, but I think you want to change culture in a different way first. Staying on this topic, when we're talking about implementing continuous delivery, the Accelerate talks about 5 key principles. And first principle is work in small batches. The other one is build quality in. Everyone's responsible. The third one, relentlessly pursue continuous improvement. And last one, computers perform repetitive tasks, people solve problems, right? And this is really talks about automation. So the only last principle where the automation is really the key. And all the previous one are really about the culture, and culture in your team, and culture in your department, culture in your whole organization. So I want to talk about working small batches because to me it's probably one of the most important, maybe one of the most overlooked sometimes, one of the most obvious in other times. So like, of course, that's what we want to do. But I'm going to talk a little bit about my journey, kind of thinking about that, talking about that, sharing my thoughts internally, discussing it with multiple teams. Okay, let's start by like, well, why would you want to work in small batches? And the number one thing is it provides faster feedback. And this is probably the thing you would want to consider. If you work on something smaller, you deliver it all the way to users, you get feedback, you can start react to this feedback instead of waiting for a longer period of time working on something larger. Because of this feedback, you can improve your quality. Because of this quicker feedback, you can also avoid sunken cost fallacy by trying to invest into something which will not succeed, but because you already invested so much time and money into it, you just continue going into this direction. So if you get the feedback early, if it's only a small batch, it's like much easier psychologically just to throw it away. And because of that, you can also reduce risk because failure is always an option, and it's much easier to fail on something small than on something large and on a big project. Right. So this is kind of the theory of it. There is one aspect which accelerate, demonstrate, and I think this is like very important of this property of working in small batches. It's again this chicken and egg problem here, is the accelerate states the goal of continuous delivery is to change the economics of software delivery process, making it viable to work in small batches. Right. So continuous delivery goal is to reduce the cost of the delivery process and allow teams and organizations to work in small batches. However, to apply this continuous delivery, you also want to do it in smaller batches, and they actually prove it in their model that if you look from one direction and look from another direction, and then also combine two models, they kind of self-reinforce in itself. So the lean product management practices, including work in small batches, including work in progress limits, etc., they reinforce software delivery performance and vice versa. And I find that this is very fascinating. We probably should talk a little bit more about that, and because this uniqueness of this catch-22, so to speak, makes it very important. Also, it makes it very hard because sometimes it's a goal, sometimes it's a result. And you have to kind of show both examples of, look, if I do this, we can work in small batches. But if you work in small batches, we can achieve these results as well. And I found it very fascinating because of this. They do talk also about how do you measure working in small batches, and because there is different projects, different teams, different languages. You don't just measure amount of code you produce. You use a proxy measure of frequency of deployment, and how if you deploy every day, if you merge every day and deploy every day, you will tend to work in smaller batches, right? And this is that they're finding, and they say that this proxy measure was really well focusing on that. But at this point, maybe some of you, but definitely at some point myself, I was in the station thinking, but this sounds counterintuitive to me, right? It is clearly kind of conventional wisdom tells me that I want to optimize things and I want to put things into batch and then I will feel more efficient, right? And this kind of led me to dig into this subject a little bit more and ask the right question. And the right question is, what is the optimal batch size? What do I need to understand in order to make a decision about what am I optimizing for? What are my costs? And really, is it like, should I batch things together to optimize things, or should I actually split them to get more benefits? And I found this wonderful book called The Principle of Product Development Flow by Don Reinerstein. And this animation I borrowed from Kelly Albrecht, which is really kind of tried to summarize. And like, it's not the perfect picture, but it's kind of start painting the idea of like, look, you have your per item, whatever your item is, feature, block of code, etc. You have two costs associated with it. You have the holding cost, like a delay of not delivering this feature, and you also have a transaction cost of delivering this feature, right? So like if you batch it together with something else, your holding cost kind of goes up, but yet transaction cost per item, if you have bigger batch, will go down, right? And the transaction cost, I take it as like anything which is associated with development deployment, and then cost of delay is really what the holding cost is. But there are other aspects which we cannot represent on this picture, is like quality and risks, right? This problem is potentially even more interesting. But what we can see here is that if you are reducing transaction cost, you give an option for people to work on smaller batches, right? That's what we're trying to achieve with continuous delivery, right? You reduce transaction cost and you getting this ability. I usually talk about this example when trying to explain it. More eggs. So let's say you want eggs for breakfast every day. And let's say one person lives in an apartment in the middle of the city, and someone else lives somewhere remotely. And when you live in an apartment, your grocery store potentially downstairs, and we live in the middle of nowhere, you have to drive like half an hour, maybe an hour to the closest shop. So if you live in an apartment, your batch size will be smaller. Why is that? Because the transaction costs just go downstairs. All right, your holding cost, potentially you don't need to buy such a big fridge because your batch size is smaller. Maybe you don't even need to put them in a fridge at all because you get all your groceries from downstairs and you don't need to store them. On the other side, you're probably going to have to go to groceries once a week, maybe once every two weeks, because to avoid paying this cost of driving there and back, petrol, maintenance, electricity, etc. And you probably have to allocate quite a big space for a fridge where you can store all of this produce for some time. And the quality, well, if you get your eggs every day, it's going to be fresh. If you get them once every 2 weeks, they're probably not going to be as fresh. So I found that this analogy works really well when talking about that. But what about the transaction cost when we deliver software? I'm sure you've seen so many delivery pipelines in your lifetime. This is yet another one. This is the one I use. We developing a feature, proposing a change, merging it to main branch and trunk. Then we convert it to an artifact. We publish to some system, which we start deploying it through stages. I think majority of people kind of do that. You might have one stage straight to prod, you might have a staging environment, a user acceptance environment, and you might flip some feature toggles, right? So what does the transaction cost consist of? I think it consists of process time when something or someone is actually working on this item, right? When I'm working on this code, someone's reviewing this code, when the automated process potentially builds an artifact, when automated process deploys through stages, there's some action happening, right? But there is also this, I always say, hidden wait time or queuing time when nothing is happening with this item, right? We don't often think about this, like at least I haven't for a while, I haven't thought about this idea, like, look, this item is sitting there and nothing's happening to it, right? It's waiting for a code review, it's waiting for the automated process to be, waiting in the queue for some automated process to pick it up and deploy somewhere, right? Or some other time. And if we can reduce this wait time, sometimes it's a free time. Like nothing's happening during time. If we just can remove it from the queue and take it straight to a particular item, we just saved ourselves a lot of time on delivery. At this point, I usually use an example of a pull request and a code review, right? The favorite time, everyone's doing code reviews, right, folks? Of course, we talk about working small batches. So let's say we have a pull request with 10 lines of code and pull request with 10,000 lines of code, right? Which one you would want to review? Left. If you have 10 lines, processing time will be short, likely a small change, potentially easy to understand. On average, feedback is going to be quicker, and therefore the requests are more likely to address comments quicker because they're unlikely to switch to something else. They will just like, okay, the feedback happens maybe in a few minutes, or maybe half an hour, I can easily jump back and start addressing comments. Therefore, the wait time is actually going to be pretty small. Like, it's a small one. I'm going to jump on it straight away. Folks will address comments straight away. We can kind of be done with it quickly. When it's a huge pull request, right? You will, okay, well, I need time to digest it, right? I need to understand if there is one feature or multiple features. Why does it have to be so long? Feedback is longer. Because of that, wait time is going to be longer, because like if I see 10,000 lines pull request, I was like, okay, let me find time to review it. I don't know how long it's going to take me to review it as well. Maybe it's going to be a day, maybe a week, maybe longer. It's hard to predict. And because of this, request, of course, going to switch and start working on something else and switch back to address comments will take for them time. And last but not least, quality, right? For quality, I dig this tweet from actually 2013 now, where I'm a developer posted on 10 lines of code, 10 issues, 500 lines of code, looks fine, and just merge it. Right, so the quality is, you're going to be more thorough, and it's easy to ask for changes. Like, it's only 10 lines. If it's going in the wrong direction, like, hey, let's just change it and move along. If it's 10,000 lines, you look at this and you feel pressure to merge, right? You're like, well, we already spent so much time. Maybe we could improve this, but I cannot really possibly ask people to make those changes. And therefore, you're like, okay, well, let's just let it slide. But also, you're going to miss things, right? It's impossible to look at 10,000 lines and spot all the possible things. So it's kind of, hopefully, like, is it familiar story? Like, people say, yeah, we know about that. So again, this is not just my observation. State of DevOps report from last year, they have, one of their key findings is that you can unlock software delivery performance with faster code reviews. And faster doesn't mean sloppy code reviews, right? It's not like, looks good to me, just merge it. But it's like really understanding that the code reviews, asynchronous code reviews, potentially slow you down, and that you want to look into this and potentially unlock up to 50% more delivery performance time. Of course, if your code reviews are already fast enough, you're going to tend to find the issues somewhere else, or improvements in delivery performance somewhere else. But coming back to the title of the talk is like, okay, what can those culture discussions and this cultural barrier of like, you know what, it's more efficient to batch, how can we overcome it? And all of the discussions do make a difference. And I've done it in my new team, where we look at, we have the conversation about all of this, multiple examples, and we looked at the pull request 5 months prior and 5 months after we had this discussion, and we ask ourselves, do those pull requests on average smaller? And they were, and we're like, oh, okay, it's great. So it's almost 40% reduction in the size of the pull request on average, or observed after having this culture discussion. But, and we only get like 20% more pull requests, increased in number of pull requests. So, but the next question is, does it actually affect the lead time? And we actually were 50% quicker on merging them than before, right? Again, it's not just because the batch sizes were smaller, but it's also about the culture discussion. And I think it's quite interesting that having this discussion can allow us to get these numbers. Again, this is one team. Yeah, we have a lot of pull requests, but it's hopefully sharing that helps you to like have a conversations with your teams if you find that this might unlock like extra performance. So kind of finishing up with this, again, code review is just one example, right? I'm not here to say that code review is the thing. This is just an example. Look at your whole delivery pipeline and think about, okay, what are my transaction costs? What are the risks? What are the established practices there which force me potentially to batch, which force me potentially to choose a larger batch size, right? And when you kind of start to figure, and how to figure it out, one way to do it is reduce your batch sizes, let's halve them and see what is particularly painful. Because what I found that if you reduce your batch sizes, and you can go to extreme, like the original continuous delivery books, they talk about like, okay, well, change one line and see how long does it take you to go through the system all the way to production. And look at where your processing time is, and look at where your wait time potentially is. Like, look at those free time in your form of wait time, which is just the item is just sitting there and nothing's happening to it. And if it's painful, do it more often and optimize away, automate away. So yeah, so I'd say it's easy to try. Do whatever you do, right? Look at what you're doing right now, have it in whatever measure you want. Lines of code, features, time, try to have it, and then try it out and see what happens. It might work, it might not work. You have to adjust. Maybe you have to have it more. Maybe you have to increase it a little bit. And with that, that's really the message. Thank you very much. Any questions? Yeah.
I'm really struck with my background before software was in operations research, and this is the Toyota method, right? What we know as lean. And,
yeah.
When I think about this in the context of CD, one of the things I found myself going around is that the amount of friction that's built into large batches is a perverse incentive for technical debt, right? And especially in this world of CD, where the answer is just like, wow, we have built up so much of a throughput backlog that we want to just don't worry about that. I think about Jenkins in terms of the tutorial, because I didn't go through it, but I blame Docker. But the fact that the incentive to work backwards is, I think, is very neglected. I think you made a comment about how platform engineers are going to tell you to fuck off. Yeah. Because it still doesn't do enough to push the transparency backwards. And I guess what I'm asking is, to what extent does the back half of the release process influence the thinking upstream of developers? Because ultimately, if I go all the way back to Japan and Toyota, the whole idea that Deming introduced was, if it's slowing down, just stop everything. And everyone, fine, that's what Kaizen originally meant.
Yeah.
And so I'm wondering, to what extent did the left half of your graph, right, on the other side of the PR published, what have you, to what extent did that change, or was it really just a big gain in sort of post-merge world?
No, it definitely both, right? And and I think what you're saying is, you need to find your bottleneck, right? And once you fix it, you're going to have another one. And when you fix it, you're going to have another one, right? And but you have to look at your whole pipeline, because you might be automating something, and it might go from a day to like half a day, but you have another bottleneck somewhere in your pipeline, which is going to be 7 days or whatever, no matter what, right? Unless you see it. So you might be automating something, and you not have much impact on your performance, right? So in our example, we just wanted to look at like having the culture discussion really made a difference or not. And in our case, it did. But we also had other discussions about, okay, well, how do we split our product? How do we look at our stories? How do we look at all the other stuff, right? Of course. And then we looked at other things like, okay, well, we have user acceptance testing. Okay, how long does it take, or why does it take so long? What can we do to automate it? What can we do to push it left? How can we get to faster feedback? Right. At the end of the day, it is about faster feedback, and as you say, like optimizing for this, but also changing the culture of, like as you said, something's slowing down or something breaks, okay, everything stop, everyone jump on it and fix it, right? This is a culture change. This is a discussion to have internally to say, like, look, we don't want our pipelines to go red. And if it goes red, all hands on deck to try and fix it. This is a culture change, and if teams have this conversation, fantastic. But many teams just assume stuff, and then it leads to friction because half of the team understand it and half of the team don't, and why that?
That's where you get the cultural food fight.
Yeah.
Which is, by talking about shift left, which is, if you people had screwed this up to begin with, right, I wouldn't have this compliance law. And very often, the people are doing these relatively small commits, back to the comment. These are not the most experienced people on the team, right? So we're going to punish them because they're new. Of course, that's the easiest thing to do. That's also
No, that's the wrong thing to do. Let's all agree on that. Any other questions? Yeah.
You have a slide about reducing the size of community requests and also the time it took to get them through.
Mm-hmm.
Do you also have quality metrics in place where you have seen an uptick in?
That's a very good question, and no, I don't have this information. But anecdotal evidence, yes, we get to higher quality as well because we get faster feedback. The impression is like, yeah, people felt like, yeah, it was worth it.
Yeah, I would expect even greater percentage in quality than 39 and 40%.
Yeah.
If there's no metrics, then.
Yeah, well, as I mentioned, I'm a part of Automated Testing Guild, so this part of the discussion as well, like we are writing tests, and sometimes first.
it reduces the agony index.
Yes.
Right, and that helps facilitate culture. When the
Yeah.
quality is shit, then people leave.
Yeah, yeah. I didn't have that study done, but yeah, like anecdotal evidence suggests that yes, people are happier and it's actually safer and they feel more confident. But I don't have this like scientific proof. But Accelerate details this metric, so like I'm just, yeah, it's yet another point, but. Go and look at Accelerate, which proved it with statistically significant analysis that these things do work.
Doris says much the same, right?
Mm-hmm.
If you look back over time, that's what they reduced, when they reduced safety.
Yeah. Anything else? Thank you.